So we're going to be making a 400 watt LED. This one here was the 200 watt LED homemade flashlight that I made out of a boost board, 2 100 watt LED chips, and a heatsink cooling fan. My buddy wants 4, so we're going to double it up. It runs off of 2 lipos over here on the top right. You can see them. And this is going to be 400 watt. I don't know the lumens on this, but here's the microchips. I'll give links to all this stuff using some 12 gauge wire and some 14 gauge wire on it. And the biggest name in the game is keeping them cool. I got this idea off of YouTube, but it needed a lot of tweaking. A lot of the stuff that I saw on YouTube on making these really wasn't 100% accurate. Okay, we're going to be gluing these LEDs. They have to be glued to the heatsink with thermal glue, and that is to effectively transfer the heat that these LEDs generate to this block. There'll be a cooling fan on the back of it. Really important with these LEDs, I'm not sure if you're going to be able to see it, there is a positive and negative on them. Positive, that's a solder point right there, but these are also solder tabs right there where you can make your connections. Positive, it doesn't really make sense because there's positive here and then negative here. But what you can see is this band. Let me get a pointer. That band is broken right there. So this is the positive side. And that band's broken there. And then the negative is broken there. So positive, negative. And we're going to paste them down. And then we got these bezels with these dimples fit into the dimples on here. These big reflectors go on there. And then the bezels that I just drilled and tapped. And you can see that's the LED there, but you could really disperses the light well. Alright, I'm going to get gluing, and I'm going to screw these down to hold them while this thermal paste dries up. Okay, time for the next one. And we've got two. Actually, we've got two heat sinks with 4 LEDs total on them. And now we're going to get into making the frame, because what we want to do is we want to have this basically. That'd be the front, and then we need to arrange these circuit boards behind. And what I'm thinking of doing is putting this underneath like that, and then mounting these somehow. I have to leave enough room for the fans in there. So let's get to work on the frame, some bending. too. I think I like the color temperature of the one that I'm building right now a little bit better, but this is basic kind of proof of concept. Nothing fancy, but it does work. So the GoPro ran out of batteries, but I got on a little bit of a roll last night. The only thing that I didn't film was the winding of these wires, and then, you know, hooking them up into their respective places. The cooling fan wires, and you can see the cooling fans are attached. That is with foil tape. They're attached with foil tape up here, and then also on the bottom. I riveted in the supports for the boost boards, and just ran the wires, secured these down with foil tape as well. The foil tape holds really good, and I like it because you can just cut it and get it out. But that's where we're at. Well, with the oldest excuse in the YouTube book, my GoPro battery died while I was getting this thing finished up, but I got new batteries on order, another memory card. But this is the finished unit here. I still have to check voltage, which I'll show you guys, but this is it. It's 400 watt LED chips. And they have been thermal glued down to 2 aluminum heat sinks, and the 2 aluminum heat sinks have been thermal glued together. You can see that kind of bubbling over. And I used a lot of foil tape on this thing. And foil tape is pretty strong. It can really hold stuff together good. What you missed was the fabrication of this bracket. These 2 rocker switches in here, they're DC rocker switches, 250 watt rated, and I used super glue to insulate them. I really can't get a good shot. I used super glue in there to insulate them, just in case they you know, make contact. I don't want them to make contact. So, but that's in there. I mean, pretty simple. It's screwed here. It's screwed to this bracket here, and then used foil tape here to tape it on, kind of clean it up. Nice little point here. I had to rearrange both of the wires that run to each of the 2 100 watt LEDs over to this side to make room for that. But yeah, that's 400 watt LED chips, as I said. This is a 600 watt boost board. I'll put a link in the description. There's 2 of them in there. Basically, this is 2 in 1, running independently on 2 switches. The cooling fans are very necessary. Some people look at this and they say, really? And it is. They get super hot. You put your hand in front of this while it's on, and it's actually pretty warm. The cooling fans do an amazing job. These heat sinks do an amazing job of actually keeping it cool. My favorite part of this whole thing is the underside. The underside kind of looks like a seat frame from like an old airplane or something. But again, you'll see more use of foil tape. Really strong stuff. The lipos mount here, I'll show you that, and I built these little shelves here. I have to round off these edges just so they don't poke the lipo. And that's it. That is the unit. I will take it outside and show it to you in the dark. But like I said, I want to show you how we get the voltage set on here and the lipos mounted, and then we'll fire it up. Got the multimeter out. This is an awesome multimeter. I got it off of Amazon. I want to say like $20-something, maybe a little bit more. I'll put a link in the description. Just really briefly, what we're going to do is we're going to measure voltage on this. So on this multimeter, we're going to click it to voltage. Now we've got our common or ground black in the common, and then for measuring voltage, we've got it on this side here. This side is for measuring current. So that's going to be how much it's pulling, and we'll do a current measurement on this thing too. These boost boards, I've had odd luck with them. These claim to be able to adjust current, but it's not as fine control as the voltage. So let's get set up here. Let's hook the batteries up and do this. It's 32. It's probably okay. I should be doing this without the light on. You can see the voltage is just dropping slightly, and that's because the battery runs out. But I'm happy with that, 32.3. You can see the voltage drop back down. Okay. Let's do this side. It's pretty good. 32 and change and dropping. I'm happy with that. Alright, I'm going to skip the current measurement because I'd have to go through taking all that stuff off again. But if you wanted to measure the current, what you would do is you would disconnect the negative. You would place the, you disconnect the positive. Hook the positive up to this side. Hook the negative up to this side. Move the red wire over to the amps. And then flick that sucker on while making that connection, and it would show you how many amps you're drawing. But I'm going to turn this on here now just for a few minutes and just see how it does. And you can see that is incredibly bright. I'm having to squint here. I'm not sure how it's looking on camera. There are fans running in there. Insanely bright. Outside with it, and got my digital voltage readouts on it, and we're going to compare it against this little flashlight. Now this is a pretty decent flashlight, and it's got a pretty decent sized chip. I don't know the specs on it. Well, let's just do this. Out here, I got a wood pile. See that little square? That's my wood pile there. And there's my shed. And then let's go like up in the woods. You can't even see that with like a... Yeah, you can't even see that. I'm like shining up my fence post. Okay, but like, that's my shed with an average flashlight. Average LED flashlight. All right. There it is. It is bright. Thanks for watching.